I'll just kind of introduce Michael a little bit. He is an author. Michael Dowden is an author. He and his wife wrote at least one book together, but then Michael also is the CEO of a company called Andromeda, and he's worked. Are you the CEO of Flex Park as well, Michael? Is that your official title?
Yeah,
Park.
unfortunately, I have
Okay. Oh.
that all those obligations.
Yeah. Well, he has his hands in a lot of things, but yeah, Flex Park and Andromeda, and then he's just an all-over great like tech leader. He's a speaker, a Microsoft MVP, and then of course an Angular GDE. So a very accomplished, highly sought after speaker, and I'm really excited to have him here today. So he's going to give his talk from horror story to fairy tale, writing code people want to read. But Michael, we kind of talked about this before
Mhm.
you came on, and I just wanted to see like what you're feeling, given all of your experience and everything you've done with your career, what do you think makes a quality programmer?
I would say a quality programmer, a quality software engineer is someone who behaves ethically and conscientiously and understands that software engineering is not just about technology, but also about the people who work with the technology and use it every day.
I like that. Okay, well, with that, then I will turn the time over to you.
Awesome. Thank you so much. Appreciate the introduction, and I'm excited to go through this. So, fair disclaimer, this is an hour-long talk that I'm going to cram into 20 minutes. So going to abbreviate a few things, but hopefully you'll still get the same impact out of it. So I'm really excited to get through it. So when we're building software, there are a number of different goals that we have with relation to that software. There's a number of different implicit things that we're trying to accomplish. The first and most obvious is that the program we're writing does what it's supposed to do, right? That it meets its expectations. But also, we have this implicit goal that we build software that doesn't have bugs, that we build software that doesn't have security vulnerabilities, that the software that we write is easy to use. Um, and another big goal we have when building software that's not always talked about is that we want the code itself to be as easy to modify as possible as requirements change because things change over time. Maybe our users want one thing today and they want something else tomorrow. We have to be able to adapt to that situation. So this is one of the things that we're trying to accomplish with the way we approach software development. And when we are software developers, there's a lot of different activities, a lot of different places we spend our time. One of the things we spend our time on is actually typing code, right? But I would say that's probably the minority of the time we spend, even as a really active software developer. We spend a lot of time brainstorming, trying to come up with how to approach the problem, doing problem solving activities, maybe um, trying to find the right algorithm to use for something. We spend time in meetings and in conversations and in discussions about the process and things we're doing. We spend a lot of time testing what we build to make sure that it meets the expectations, but also that we haven't left any problems for the users to stumble into. And finally, we spend a lot of time doing documentation and writing about things other than the code itself. So typing the code, coding is only a small part of the things we do. There is something that is common between all these activities, something we do for almost all of these, and that is actually reading code, whether it's our own or somebody else's. So, a quote out of the book Clean Code: the ratio of time spent reading versus writing code is well over 10 to 1. We are constantly reading old code as a part of the effort to write new code. Therefore, making it easier to read makes it easier to write. And another quote, this is called Eagleston's Law, unknown where the origins are, but it's been around as long as the internet. Any code of your own that you have not looked at for 6 or more months might as well have been written by somebody else. And that is just a reminder that when we are trying to make our code easy to read and remember and understand, we are actually doing ourselves as much of a favor as the other developers we work with. And finally, and one last quote for you: Any fool can write code that a computer can understand, but good programmers write code that humans can understand. Is really illustrates the fact that the point that I'm trying to get across, which is that code readability is highly impactful and an important part of our overall communication. So we'll get into that in just a little bit more. I want to thank everybody for the introductions. I think everything's already been covered, but I've written a few books, MVP, GDE, and run a number of companies. I'm actually going to a convention next week to try to get Lorelink launched, which is one of our new gaming products. So really excited about that. So horror story. Let's start from the beginning. We're going to tell a fairy tale. We have to start with a horror story. So here is a horror story. This is a code sample from the daily WTF. And I'm sure that you can look at this and immediately understand what it's doing, right? No. The answer is this is convoluted. It's going to take time to figure it out. You're going to start looking through it, and then you're going to have a lot of questions. We're converting a hard-coded date. Why do we have a hard-coded date? That already is questionable. We're going to convert that to a date time object. Okay, that seems to make sense. But then we're converting that date time format back to a string again. Okay, that doesn't make sense. And then we're converting that string back to a date and time again. Okay, now I'm lost, right? So why do we have this code? How does it make sense? And at the end of the day, we get down all the way down to the bottom, and all we're doing is returning a true or a false. What? So there's a number of factors about this code that makes it hard to figure out, and it has to do with the naming choices. It has to do with the structure of the code, the fact that there's no comments, the fact that we're going back and forth we're doing a lot of like what seems to be uh, like data type manipulation for no good cause. And it's not clear from looking at the code why we're going all the way down to the end and just trying to find a true false, or what is the point of this? What is the intent? So we're missing semantics, we're missing intent, it's kind of got some ambiguous things. And this is an example of the cognitive load that it can take to understand a really complex or tedious bit of code before we could come in here and make a change. If we wanted to change the outcome because this code had a bug that we're trying to fix, how would we approach figuring this out? Now we need to maybe break it down. Maybe we need to refactor it. There's a lot of steps involved because the code itself is not easier to understand. Let's look at a different example. Switch on cases, right? So we've got do the same change in shop on inventory integration direction. Do the same change as what? Same implies that we're comparing to something else. Same as what? And so this is a case where we have these really, really, really long identifiers. They're very verbose, but without any context, they're just as convoluted as if we used a single character to represent our variable names because they're not actually conveying the meaning or the intent of what's going on. So now I have something that's long and unhelpful instead of short and unhelpful. So it's still unhelpful. Look at one more example. Really quickly, is it going to return true or false at the bottom? How many individual Boolean statements do we have to get through to realize where we're at? Because we're applying not so many times. And this also leads to another just kind of a little bit of trivia, and that is that our brains want to think of things as true rather than as false. So we tend to invert logic to make something true instead of thinking about things as false. So when you have this thing that's not result equals false, now we have a double negative. We've got the not and we have the false. And so our brain is constantly reading through this whole line of things, trying to turn all of these negatives and nots into positives. And it takes time for us to do that. And it can cause us to make mistakes. But why do we care? Why do we care about all this? Like, so what? It's code. I get paid for this. It doesn't matter if it takes me a couple hours to look through this stuff, whatever. How does this stuff impact my life? How does it impact my work? How does it impact my company? The first is that a key part of communication in general is speaking a shared language. This means that we need to do things like avoid anything that is confusing. Ambiguous acronyms and jargon can be part of this process. We want to make sure that we are sharing a language and speaking in a way that makes sense with each other. Code is a form of communication between developers just as much as it is a form of communication between us and the computer. Also, a lot of developers switch jobs regularly. In fact, 2 to 4 years, there's a lot of turnover. We hire contractors, we hire new teams, our teams grow. This means that we need to be able to bring new people into our teams, onto our projects, and have them be successful and be able to do things. When our code is convoluted, when it is hard to read, when it is hard to understand, when we do things in kind of our own team special way instead of following industry conventions, this onboarding time can be much longer. It can be a lot harder to bring new people onto the team and have them quickly be able to deliver value. Inclusivity. We want to make sure that people with different backgrounds, that people with different levels of education can still come in and have access to this industry. Some of the very best developers I've ever met in my life don't have college degrees in development. And I think there's nothing wrong with that. I appreciate that. But when we write code in a way that is unnecessarily ambiguous or archaic or arcane or difficult or challenging, we are creating artificial barriers to entry for new people to come into the industry. And we want to try to avoid that. Accessibility. Part of writing good, clean code means writing semantic code, especially important for things like HTML, but that can be an important part of accessibility. We don't want bugs. And so the cleaner your code is, the easier it is to understand, the easier it is to find errors, to identify them, to fix them quickly. And finally, you get down to naming. And naming is an important part of code quality. How do we choose to name our identifiers and our functions and our classes? And it's just one aspect, but it's an important part of readability. So we're going to dig into this just a little bit. This is a famous quote from the early days of the internet. There are only two hard things in computer science: cache invalidation and naming things. Of course, there was another very popular version of this quote from Leon Brambeck that says, there are two hard problems in computer science: cache invalidation, naming things, and off by one errors. But this is hard. The point is that of all the hardest things we come up with on the technical side, coming up with good names for things is just as hard as any of the technical challenges we're going to run across. So when we're trying to come up with good names, when we're trying to come up with good language and communication for our code, one of the things we're trying to do is prevent ambiguity. When I say there, what do I mean? The answer is you don't know what there means unless you have context. Why? Because it could be any one of these things. And English in particular is full of things that sound the same but mean different things, or look the same but mean different things, like read versus read. We need to make sure that when we are choosing words, the words have a specific meaning and it is clear not only which word we're using, but which meaning we intend for that word. That's an important part of avoiding ambiguity. As an example, when I say free, what do I mean? If you're familiar with the open source community, you understand this argument. It happens all the time. Does free mean I don't have to pay any money, or does free mean I can use it however I want? Free as in liberty versus free as in free of cost are two different types of meaning of the word free. And in specific contexts, this can be actually tremendously confusing and can cause fairly big conflicts, actually, as we've seen. So we want to avoid that sort of situation. But enough about that. Let's get into the fairy tale side of things. How do we make things better, and what are some things we can do? Well, first we can do some assessing. What criteria can we use to kind of make decisions? So let's say, have you switched jobs at least twice? Have you switched jobs a few times? Have you encountered communication problems when you joined a new team? Have you joined a new team and suddenly every single thing that you were familiar with has different terminology? Maybe one team had stand-ups and another team has their daily check-ins, even your meeting names can have different names, right? And so one of the things that we need to do is kind of weigh when is a name, when is a bit of communication good or bad, and what are some things we can use? One thing we can use is semantics. This is the branch of linguistics and logic that is concerned with meaning. In code, this refers to choosing the right words and structures to convey the intended meaning. For example, am I going to process a user or log in a user? Both are correct, but one is providing meaning, whereas the other is totally generic. For example, if I'm in HTML, if I use a div tag, it's not giving me any indication about what I'm doing with that structure. But if I provide a nav tag, now we know this is a navigation section. It provides meaning and intent, meaning around that section of code. So it's providing semantics. Vocabulary is also really important. The words being used are only meaningful if they exist within the shared vocabulary of those reading in the future. So, for example, reciprocal. What does reciprocal mean? In mathematics, it means the inverse of something in general. It can be in relationships, reciprocity means that if I do something for you, you do something for me. Completely different meanings, completely different contexts. If I say Ray, what does that mean? Other than obviously it could be someone's name. In mathematics, it can be a line with a starting point and no end point, whereas in zoology, maybe it's something that swims in the ocean, right? And this is where the context matters, making sure we're working with the same vocabulary, we're working within that same context. And this happens within related industries sometimes. So I've done a little bit of work in both insurance and banking industries, and it turns out that sometimes you'll see the exact same words that mean slightly different things because they're both financial services. There's a lot of similar types of things that are going on, but they may have slightly different industry specific definitions for things. And so it's really, really important that you have extreme clarity over what you're talking about when you're using specific industry words. Intent is very important. We want to use word that indicates how and why we would want to use a thing. So convert time tells me what's happening. It's semantic, but it does not convey the intent as it to when I would use it and how I would use it and why I would use it. In this case, I would like to convert local time to a UTC time. Check username. Okay, I'm going to do something with the username. I'm going to check it for something, but maybe what I'm checking is that username available? So I can use a name that gives me a better meaning of intent. I know when to use it. I know what's going to be happening with it. Another thing, and this gets to what we were talking about earlier, is disambiguation. Make sure that the intended meaning is the one that is conveyed. So for example, execute could mean to run a process or it can mean to kill something. We need to be very clear on that, and maybe if that would be ambiguous in the way we're using it, choose a different word that would not have that same type of ambiguity. Light, for example, does it mean it's not dark or does it mean it's not heavy, right? Those are both perfectly valid uses, but there would be cases where those could be super ambiguous. Another thing that comes up for us sometimes is that a lot of the code we write is temporary or ephemeral. And this is a fundamental component of a lot of agile development methodologies. Is something that happens a lot. And what this means is we can end up writing code that is only valid for a short period of time. For example, here's a function that is valid for exactly once. I rolled the die to get the number, therefore I know it's random, but it's technically only random the first time I call the function. After that, it's not random anymore. This is very ephemeral. So one of the things we do a lot when we're trying to maintain our code bases, maintain clean code, and keep things working well is we're going to do a lot of refactoring. So let me give you an example of when refactoring might make sense, or specifically when refactoring can come with side effects that we need to be aware of. So we have this bit of code. I'm going to use CSS because it's great for illustration. So I've got this class that says write, and I've defined write to mean text align right. In other words, I want the text on the right-hand side of a column, for example. And as you can see, when I apply write, these are right aligned in their columns. Perfect, no problems. But I've got this class right, it right aligns things. So now I've also used it in this other situation where I've got a counter on the number of characters in a box. Same class, no problem. There is a problem though, because what's going to happen is I decide that I want to change the style for one of these scenarios to this. Perfect. That's exactly what I wanted. The problem is that now that same exact thing has happened here. What's the problem? What's the consequence? The issue here is that we used a class of right to, which it doesn't convey any semantics or any meaning. All it's doing is telling me I want something to be on the right. What's interesting about this is that in a lot of um, web libraries, for example, there's a class right, and sometimes it's going to be float right, and sometimes it's going to be text-align right, and it may even have other definitions. So it's not super clear how it's being implemented or why I would use it that way. And this is a place where code reuse can actually be a problem. Sometimes dry, don't repeat yourself, is actually very dangerous because if we have code that is being used in a lot of places but doesn't have clear intent or meaning or semantics associated with it, it's not clear the fact that the use in one place and the use in another place are going to diverge, as we've seen in this example. So the really easy way to solve this is that I give it a better name. Instead of using the right class, I have a numeric column class, and I want numeric columns to look like a specific thing. And even though it started as just text-align right, and another thing may also have started as text-align right, just because the code implementation is the same, does not mean that the intent, that the semantics, that the purpose behind it is the same. And code should never be reused or shared if the intent, meaning, or semantics are different, even if technically that you're using the same line of code. And so in this particular case, we can use a character counter. It starts as text-align right, but then I apply a bunch of other styles to it, and there's no problem because the only place I use this is when I have a character counter. So here's another example of refactoring. So this is a situation where more than likely what happened is in an effort to keep code clean and readable, somebody implemented a really hard rule that said you cannot commit any function with more than, let's say, 500 lines of code in it. But somebody ran across a function that has like 1,200 lines of code. So rather than doing something that would break it down in a logical way or really refactor the code in a way that's nice and easy to understand, they did the expedient thing in order to be able to actually commit their code and without violating the rules. And that is they broke it into 3 distinct sections and just called them one after the other and went about their day. This is impossible to read. This doesn't mean anything from this context. Now I have to look at 3 functions to figure out what's going on instead of looking at one function to see what's going on. And this is actually worse than a single 1,200 line function. So it's really important that when we decide that we're going to make changes to our code base to improve readability, that we do not implement the rules in such a way that we incentivize ourselves and other developers to make bad choices just to be able to pass the rules that we have in place that were intended to make the code cleaner, because then we can end up in this situation where we have actually made the code worse. Another interesting example is typos and misspellings. And I don't like to harp on this because there's a lot of reasons that someone may misspell something. First of all, you simply have the spelling differences between, say, American English and British English. Neither are wrong or right. They're both perfectly valid. Also, they can be maybe somebody is writing in a language that is not their first language. They don't necessarily know how to spell it super well. And I think it's inappropriate for us to do anything that would make fun of or shame anybody for not being able to spell well. There's all kinds of things. They may have dyslexia, any number of reasons. They're perfectly valid reasons. There's nothing wrong with it. But we have to be very practical and pragmatic and understand that regardless of anything else, it's important that we are consistent with our identifiers and our naming across our code base. Because what happens in a situation like this, where there's a bunch of different like typos or misspellings of a word, When I go through my code base to try to refactor it and change something, and I'm using find and replace, I'm using regex expressions, whatever, to find all the things that I need to fix, I can't do that effectively if there are inconsistencies with how we have written and coded things. So it's super important that we check on this and try to be at least consistent. Just for example, choosing between color the American spelling and color the British spelling, we need to be consistent. Pick one and use it in your team. It doesn't matter which you use, they're both perfectly valid, but you need to be consistent or you're going to have problems like this. So in conclusion, let's go through a quick checklist of some things that you can do to try to help maintain your code base. First, consider your audience. The next person to touch this code is most likely a developer who did not have or does not remember the conversations, the context that is in your head at the time you're writing the code. You're going to forget things, so make sure that comes along for the ride. The next person doesn't have access to all the external context. They are going to be busy and distracted. Let's keep that in mind when we're thinking about how to write things and how to document things. Names should be specific and written in the common language of your problem domain. Try to avoid things that could be ambiguous or be abbreviations. Be really specific. It's not a tax, it's a sales tax rate. Tax, for example, it can be a rate, it can be a number. Which is it? Am I adding this or am I multiplying this by something? Give me enough context in the variable name to know which it is. Um, in general, actions should be verbs. Function and method names should include a verb that helps you know not just what it does, but what it operates on and what it's doing to it. So in this case, it's not just a sales tax function, it's a calculate sales tax function, right? It's not an order quantity function. That doesn't mean anything. It doesn't tell me what we're doing. We're actually fetching the order quantity from somewhere. That's fine. So make sure to include those actions. And try to use the full word. I mean, some common abbreviations are okay, but best use sparingly. And it's specifically important if there could be any possible confusion, either within the problem domain, like maybe you're in an accounting business or you're in a manufacturing business, there might be some common abbreviations, but what happens if there is an abbreviation in the tech world with an abbreviation in the manufacturing world that mean two totally different things, but they're both commonly used within those industries. In that case, we don't want to use those abbreviations because we're not sure which domain we're communicating in. So, for example, we might want to, and don't use misspellings of things, just use different words like class versus class name, stats versus statistics. One that comes up for me a decent bit, one of the products I'm working on right now, I said Lorelink, it's a it is a piece of software for game masters for role-playing games. A lot of characters in role-playing games have a concept of a class. You know what else has a concept of a class? TypeScript. So if we use the word class somewhere, it's not necessarily super clear. Are we talking about the types in TypeScript or are we talking about the concept within the data that we're managing? So we have to choose different words or be super clear about which thing we mean. I talked about this earlier, spelling. I don't know if you've noticed these two examples, but create was a misspelling that made it into the C programming languages, and refer with one R is a typo that made it all the way into the HTTP specification and has lived for decades at this point. So do be sure to be consistent with those. And comments. Comments should explain why or how. Don't explain what unless the understanding of the what is buried like somewhere that people don't have access to, like third-party code. Don't duplicate your code within your comments, but use comments to add understanding, right? So I'm not just iterating over the list of items in the order. I can see that by reading the code. What I need to know is what we're doing is calculating the sum. And finally, one of the best ways to start making improvements in your code base and on your just to put your team, put together this checklist of specific naming recommendations, do code reviews. And remember, code reviews don't exist to remind everyone how smart you are. Code reviews are there to provide consistency and mentorship in what you're doing. Code reviews are a great way to implement these checklists and these rules of how you're going to make things better on your team because you can decide as a team to make exceptions. You're like, hey, I think we really need to only have really short functions. Let's say 500 lines is a perfectly good, reasonable limit for a function, but we're going to enforce that in code reviews rather than enforcing that with linting rules so that we can be like, no, we all agree that this function is easier to read this way rather than breaking it up, or it's not worth our time to do that right now. Code review allows you to inject, rationality into a situation while you're trying to make things better rather than just forcing everybody to do things a specific way all at once. And finally, hopefully we're happily ever after. Remember, code exists not just as an instructions to the computer, but as a form of communication between developers. And like any other communication, we want the code to be clear, succinct, and specific. We want readable code to support inclusivity, accessibility, and the company's bottom line because we spend less time training people and more time doing work. And we should enforce these rules, come up with good rules, and enforce them through team agreements that are supported by code reviews. So thank you so much. That's a wrap.
Excellent, as always. Thank you, Michael. We've got some really great discussion going on in the chat, actually. So I would just encourage anybody from Limble who has questions or a point you'd like to maybe dig into a little bit deeper. Now's your chance. We've got about 5 minutes here for some Q&A if the Limble team members want to ask some questions. Okay, yeah, Joseph, go ahead.
Hey, thank you so much for this presentation. The one key takeaway that I can get from this is when you're writing code that really the computer understands however you write it, but is it understandable by other humans? I really like that. Yeah. And on that note, as we try to write human readable and understandable code, what is your take and opinion on the amount or the style or quality of comments, JS docs that we might want to include? Some people say that, no, the code should be able to explain by itself without having any comments. But from your perspectives, can you provide us any opinions and thoughts?
Yeah, I vehemently disagree with the concept that good code is self-documenting because that misses the point that I was trying to make entirely, which is, yes, as developers, we can read code, and the better job we've done by choosing good, clear naming, by using straightforward conventions, we can make the code even more readable. But the thing that the code will never contain is, why did I do it this way? What problem am I trying to solve? And sometimes that's not necessary, but surprisingly, a lot of times, especially in our higher level functions where where the code is tied directly to a user task, there are expectations, there's problems we're solving, there's things we're doing, and the reason we're doing it this way or what we're trying to accomplish, putting that in a comment can really open it up for us in the future to know, hey, I shouldn't change this because even though it looks a little weird, they told me they did it this way to avoid this bug or to avoid this side effect or to avoid these other problems. So I now know what to be cautious of. But also I can look at the code and be like, their goal was to do this one specific thing. I have better ways of doing that now. Maybe there's new language features that would make this much easier. If I understand what the goal was, not just how it was being done, but if I know what the goal was, I can feel pretty confident. Hey, if I go through and change this, the way we're doing this in this code to take advantage of this new language feature, I'm still going to be okay. And I can do that with confidence now. And that doesn't eliminate the need for like some testing. But one of the challenges, like I love testing. I don't love test-driven development always because the thing test-driven development doesn't always buy me is that ability. Sometimes in order to change the structure and take advantage of language features, I have to change the interface a little bit. But if I change the interface, then I have to change the test anyway. And now the test isn't actually verifying that I still have the same obligations. It doesn't prove that I didn't change anything in the implementation. So it only gets us in the real world, TDD only gets us so far. Comments can help with that.